let's create a new do file. Let's say this is a graphing. And let's get rid of all this. It's June 28th. Still not bother creating over a log file. Call this how to graph. So let's load the data. And let's load a new data set now that you haven't used, and let's do something a little different. Let's go web use. We've had this sysuse before. Now web use. Let's go life exp. Clear. And what this data set is, if you want to take a quick look at it, it's telling us by region and country. It's telling us population growth, life expectancy, gross national product per capita, and whether or not a place has safe drinking water, or a score for safe drinking water rather than it being a dummy. So maybe you want to do a few things with this. Rearrange the data, and we'll just practice with some things. We can see, well, let's make this wider. You can see right now, looks like it's sorted by region, by country. It doesn't tell us that it's sorted by that, but it kind of looks like it. Maybe we want to sort on life expectancy, because maybe that's really something that matters to us, or it's of particular interest. Now we can see that countries from the different regions on Earth, they're scattered throughout. So like life expectancy in a North American country, Haiti, is terrible because poor Haiti, they're in rough shape. But you also see that North America has a country that had high life expectancy in 1998. So it's got, you know, one that's really low and another country that's got really high life expectancy. The United States is up here, 77 years. This is years of life expectancy, by the way. Maybe we want to do a few other things. So we just, you know, did list. Maybe we want to gsort minus life expectancy. What's that going to do? Well, rather than sort is always going to sort something lowest to highest. Gsort would also sort lowest to highest, but we can tell we want it to, we can use this negative, and then it will do it in the opposite order. It'll sort highest to lowest on whatever variable we called. Univariate histograms and kernel density plots. So we worked with some of these the first day. So we're not going to focus on them, but just to remind you sort of what the commands are, and more importantly to kind of have a sense of what the data look like. We're going to look at these, exploring the data. We go like, oh, okay, life expectancy at birth, it's sort of the distribution in this sample. Okay, maybe we want hist life expectancy bin 20. Right, more bins, and we can do hist life expectancy width 2 frequency. Remember, I tend to like frequency if we have not a massive number of observations. And here's something I didn't show you the first day. This option right here, K-density on a histogram. So rather than calling them individually, we can call them together, which is actually quite convenient. And of course, you can also do like K-density, life expectancy, which we won't run, or K-density, life expectancy, normal. Maybe we will run that. You can be like, oh, it looks like life expectancy is kind of normally distributed. Bar graphs. Okay, so this is going to be something new. Maybe you want to do something like graph bar life expectancy, and I'm just going to make a note here like this is boring, this is not interesting. Maybe I won't say boring because it sounds like Donald Trump, but this really is boring because this is your graph. Cool. Like you don't learn anything at all from that. But if we graph bar life expectancy and we use the over option, we can learn stuff that's interesting. So for example, let's get bar graphs of life expectancy over region. And so using the over option then says for each of the values of region, we're going to create this bar graph. And we're going to learn the mean of life expectancy. So we can see that average life expectancy is highest in Europe and Central Asia, lower in North America, and then even lower in South America. Maybe we don't just want to do a bar graph like that. Maybe we want to do a horizontal bar graph. And maybe we don't just want to include life expectancy, but we also want to include safe drinking water. Still use the over option, and let's go over regions. And then we see that we get this. And it looks like in general, the mean of the safe drinking water variable is higher in each region than the mean of the life expectancy variable, but that shouldn't mean anything to us because life expectancy is measured in age, whereas the safe drinking water variable is just measured on a scale of 0 to 100, so they're not comparable. But when safe drinking water seems to be higher, it seems that life expectancy looks like it's higher too, at least in these regions. And maybe you're like, okay, I like that, but I don't like that it's a horizontal bar graph. I just want what you had originally. To be like, oh, okay, fine, just do a bar graph. Maybe we want to graph bar life expectancy safe water over region. And then maybe if you want to use this / option, you can go on the next line. You want to, and we'll show you how to use a better option, but maybe you want to add a title to it. So rather than just having that come up like that, we actually want to customize our graph. We can say life expectancy and safe drinking water by region. Now we see that we have this title at the top, life expectancy and safe drinking water by region. maybe that's not enough for us. Maybe we also want to have something on our y-axis that explains what it is. And now we have to run all 3 lines here. And then we see, okay, great, we called the y-axis the mean, and now we've got all of that here. You can do a bunch of other things. You can change the labels in your legend. You can change the gray background color to white. You can get rid of these little gray dashed lines. You can change the values on the y-axis, etc., etc. So you can customize your graphs quite a lot. Scatter plots. Bivariate relationship. So maybe you want to type help scatter beforehand, just to get a sense of what sort of options you have. You can always just use scatter. Two-way, if you go graph two-way scatter, or graph two-way bar, or other things like that, you sometimes can use more options. But let's just scatter LXP, and let's go gross national product per capita. So this is a good thing to do when you're exploring your data, get a sense of how 2 variables move together. That looks like a log linear relationship, doesn't it? So if we logged GNP per capita, and then we plotted the 2 of them together, gen log GNPPC equals ln GNPPC. And then scatter LXP GNPPC, sorry, log GNPPC. You see that? Yeah, this looks like there's a pretty linear relationship. And the higher GNP per capita gets, the tighter the relationship gets. Maybe we want to do something like scatter LXP safe water, and we want to put a weight equal to GNPPC, M color blue. So these are now going to be a bunch of different options, and you're going to have to go back and figure out why I'm doing everything I'm doing. At first we're going to use this slash option, but then we're going to change it up. So let's go now title safe drinking water versus life expectancy. Comma, end quotes, begin quotes again, selected countries. Now Y scale R, let's say 50, 85, graph region, color, white. You're like, that's a lot of stuff and I don't know what you're doing, but okay. But oh, look, now we get a cool looking graph. And it didn't take that much code to do that, right? We just had to know what options we wanted. But this actually seems like a very nice way of showing the data, right? I think it is.
I need to do this for my replication.
Oh,
like,
cool.
This is one of the graphs that I need to make. I was worried about it.
Well, now you have the code.
Exactly. It's very exciting.
Maybe you should go to grad school if you're excited by graphs.
Yeah, that was my conclusion.
A nice graph. A better way. Now, better is a matter of preference here, but let me show you this. So let's say delimit let's say that I don't want these slashes all along here. What I've told Stata is that I want a semicolon to be the delimiter rather than a carriage return. Just like I told you guys earlier, that's how we do that. But then at the end of doing that, I want to change the delimiter back to a carriage return. I don't want to have to keep using colons. Or sorry, semicolons. If you run that, you get the graph again, but you don't have all these slashes in there. So it's a matter of preference, but I think this is more nicely organized. I learned this working as an RA when the person who hired me said, I prefer this. And I agree with him. So maybe instead of doing a scatter plot, we want to do something like a connected graph. Now this is not a particularly interesting relationship, right? We're not really going to think of this as being like a trend. You may want to use connected or line if you do think you have a trend that's interesting. But instead of connected, do line. And I get that instead of having the dots. Maybe you want to do something like LP dash as an option. That's a nice dashed line. If you want to look at a bunch of the different options for two-way graphs, just help two-way or help two-way and then the particular type of graph that you want. Say we went on scatter, so we did like help scatter or help two-way scatter. You can see a bunch of the different things that we brought up, the options.
I think I see. So it's like a different, because I saw scatter in the two-way, but we were also using that as its own command.
So yeah, you can, so two-way is going to, you know, there are a bunch of two-way graphs. You can also do things like I don't know, scatter life expectancy log GNP PC, and then line life expectancy log GNP PC LP dash, something like that. You can combine different types of graphs, maybe not all of the types of graphs, but you can combine a lot of different types of graphs if you do something like this. Or you could, for example, you could combine two of the same types of graphs but with slightly different variables, or you could something like this. Maybe this would be useful for you. Maybe we want to do a line if safe water greater than 50, and maybe here if safe water less than or equal to 50. You get something like that. So using two-way in that way, I don't think if you put graph at the beginning, sometimes it works, but sometimes it gives you grief. So So you have these other options with 2A that will allow you to sort of, for example, put a line that fits the data along with the scatter plot that maybe helps show people, yeah, look, it does seem like it has this fit. There are other ones than just lfit, so like help 2A. You have like a mspline or LOS or lfit or qfit. So maybe rather than doing this with log GNP per capita, we just want to do with GNP per capita, but maybe we want to do a qfit. Whether you think that's a good fit or not, you know, you can decide for yourself. You know, it's going down here, so I don't know that I think that's great. Maybe you want to mspline it. So just keep in mind that you can do those sorts of things with two-way.
Would mspline, like by itself, do that? Could it like just do that line by itself? So that's like a.
Sure, yeah. So if we did like this, two-way mspline, then we just get that without the scatter plot. Now that may not be particularly useful because you're like, okay, I guess this is, you know, it's fitting this sort of through the data, but I don't know what the data actually look like, and I don't really know how good this is. Let's do a two-way connected LEXP GNP per capita L color red, and then LP or line pattern dash. Doesn't have to be dash, you can do other things like dot or dash dot, things like that. Now instead of doing this again, let's use the delimiter. So delimit semicolon X title, I don't know, X axis title, whatever you like. Y title, we already saw this one. Title, Y axis title. Title, graph title. Subtitle, perhaps you want a subtitle under your title. Graph subtitle. And then maybe we want to change the labeling of the y-axis. So y label, say start at 50, go up in increments of 10 to 80. And then maybe we want to put some node in there. Data source XXXXX. Maybe we want a size v small. And then we want to put the semicolon, and then delimit, carriage return. Use something like that, then these options will create a graph that does all this stuff, which makes it kind of nice. Oh, and note the scatter plot still blue dots, but now we have the dashed red line connecting them, and maybe changing those colors is what we want. You should keep in mind in general that papers are often printed from black and white printers, so it may be best to include just grayscale colors rather than like shades rather than colors, even if you like the look of certain colors. Now, what else? There was one I wanted to show you guys. Oh yeah. So let's maybe do like a line graph, which you can also do with two-way. Maybe you want to go like delimit line. Before we do that, I just want to do this quickly. Right. Gen year equals 1980 plus the observation. So we're creating this now. We're creating years that obviously are not actually matched to things, so this is not real data. But if we did look at that, sorry, I went back through my notes. I was just trying to skip over things I didn't think were going to be useful for you. So if we had sort of like data over time, now again, these are not real time periods, but if we did, we could say, oh, life expectancy at birth seems to be trending upward over time, although it had a sharp drop in like 1983 or something, and again down here in 2050, which has not happened yet. And if we wanted to do something more complicated with something like this, we could say drop if region equals 1 by sort region gen year, and drop year, then by sort region gen year equals 1980 plus n. So for each region we're doing this, and then gen NA for North America, life expectancy equals LEXP if region equals 2. And gen South America, life expectancy equals LEXP if region equals 3. And then after running that, what doesn't it like? Oh yeah, sorry, this should be underscore n. Then after that, we can include this line graph. NA, life expectancy, SA, life expectancy, year, LP dash, for example. And then you can include like X title year, Y title life expectancy if you wanted. We don't have to. Maybe we'll include X title year, but for time reasons we won't include the Y title. But this is then important. Legend. Maybe you want to legend label 1 North American countries and label 2 South American countries. And then maybe you want graph region color white. Put your semicolon in there, and then maybe delimit carriage return. Now when we run this, you see that you get over time for two different groups of countries. Obviously, it doesn't run properly because we created this time variable that was not real. But we get these two different groups of countries, and we get trends for each of them that we can plot against each other. And we can change that legend so that it reflects labels that we think are better than what Stata wants to do. The very last thing that I want to tell you guys about is very, very quick. It's just if you want to, say, export your graphs or save your graphs. So maybe you want to run this graph up here. And afterwards, you want to save the the graph. You can go, and there are different options. For example, graph export. Graph export, and then like proj dir out graphs explore, and then we can call it whatever you think is descriptive versus GNP per capita. So you can just do it like that, or you can tell it you want, say, like a particular format, a PNG file, and then replace. So if you run all of this, Stata creates this crappy looking graph, and things haven't been sorted, so before we ran it. So this gives you an example of how you need to make sure that you've sorted things correctly. Otherwise, remember we had that sort of back and forth stuff going on when we did this before. And because we resorted it, it looks differently now. So it's a cautionary tale. But given that that was created, it was then saved to that folder doing or using that code. And we can see there's a copy of it there. And if you don't want to use graph export, you can also, and sometimes with the types of graphs you want to save, that won't work. So you can also sometimes use graph save, and then maybe include all of this again. Maybe call it 2, and you can replace. You run all that, creates that. It saved the first one again, it saves the second. Maybe you want to save it as like a PDF or something. And then you look in your folder, and you've got the 2 PNG files plus a PDF. Now sometimes the PDFs, if you want to save as a PDF, sometimes you have to use a particular type of command. So doing graph save in this case is not the way to generate a PDF that will actually be readable. I think graph export might. I can't recall. I normally go back and look at the exact code. But point being, this is how you save those sorts of outputs to your computer. So I am more than out of time. Thank you guys so much for your attention. I hope you learned a lot this week. I'm sure you will forget a lot of it, but now that you've seen it, I think it'll be easier to go back and learn. So enjoy the weekend.
Thank you so much.
You're welcome.